What is the greatest common factor of two numbers and how do we find it? Let's take a look. Straight into an example here. So let's say we have the two numbers 12 and 18 and we want to find the greatest common factor. To start off, what is it? The greatest common factor is the largest number possible that can divide into both 12 and 18 and give no remainder. And to do this, what we're going to do is write out all the factors of these two numbers here. So 12, what are the factors of 12? Factors of 12, well, 1 is always a factor. It's even, so 2 is also a factor. 3 also goes into 12. 4 also goes into 12. 5 doesn't. 6 does. 7, 8, 9, no, and then 12 goes into 12, okay? Then any number is always a factor of itself. And let's look at 18. 18, factors of 18. 1's a factor of 18. 2 is a factor of 18. 3 is a factor of 18. What about 4? No. 5? No. I think that's about it. 9, 18. 9 goes into 18. Yep, and then we have 18 itself. I think it might have missed one somewhere there. It looks okay to me, but if you're really not sure, I can check it for you. And there's a cool way to check it. For any number, when you want to check its factors, you should always have an even number of factors. So for example, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Okay, and they all should pair up and you should have no leftovers like that. Same with this one. 1 times 18 is 18. 2 times 9 is 18. 3 times, I forgot 6. Told you so. Now give it another try and get it right this time. There we go. Okay, I'll try again now. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. Okay, now I've got them. Once you're here, you can look at the common factors. Okay, so the numbers that can divide into both 12 and 18 are, well, 1 appears in both. You look at the numbers that appear in both lists. 2 is also a common factor. 3 is also a common factor. And what else do we have? 6 is also a common factor. But the greatest common factor is the largest of all these common factors, which in this case is going to be 6. 6 is the largest number that can divide into both 12 and 18 separately without giving any remainders. So our greatest common factor of 12 and 18 is 6. Not too hard. Let's do another one. The greatest common factor for 30 and 45. So factors of 30, let's write them out. Factors of 30, 1's a factor. 2's a factor. And what else? 3, yes. 4, no. 5 is a factor of 30. 6 is a factor of 30. 7, 8, 9, 10, and 15. I think that's it. And then 30 itself is always a factor of 30. And the factors of 45, let's have a look at those. 45, factors of 45. 1, 2, no. 3, yeah, 3 is. 4, no. 5 is a factor of 45. 6, 7, 8, 9. 9, 5 is a 45, yeah. 9, 10, no. 11, 12, 13, I think 15. And I think that's it. And then just 45 itself. It's not even, so we can't divide that by 2. 45. Let's do our check again. Okay, so 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. And 5 times 6 is 30. Okay, my factors of 30 look good. Factors of 45 now. 1 times 45 is 45. 3 times 15 is 45. 5 9's are 45. Okay, I think I'm good. So our common factors are 1's a common factor. 3 is a common factor. 5 is a common factor. 9 is not. 15 is a common factor. And 45? I don't think so. So I think, yeah, if you look at the one with the least amount of factors, you'll get through it quicker. So we have all these common factors, but what is the greatest common factor? It is going to be 15, obviously. So our greatest common factor of 30 and 45, our GCF is 15. 15 can divide into both 30 and 45 and is the biggest number possible that can do that. By the way, greatest common factors come in handy later on when we are factoring or factorizing algebraic expressions. One last example. Let's find the greatest common factor of 10 and 21. There is one more sort of weirdish thing that can happen, so we just want to cover this one more example here. Factors of 10, let's write them out. 1 is a factor of 10. 2 is a factor of 10 because it's even. 3, 4, no, 5 is a factor of 10, and 10, of course, is a factor of itself. Have I got them all? Quick check. 1 times 10 is 10. 2 times 5 is 10. Looks like I got them all. Let's take a look at 21. Factors of 21. 1, of course. 2, no. 3, yeah. 3, 4, 5, 6, no. 7 is a factor of 21. 8, 9, 10. I think that's it. And then just 21 itself. Okay. Quick check. 1 times 21 is 21. 3 times 7 is 21. I don't think I've missed any. Looking good. So let's have a look at our common factors. They both have 4 factors each, so it doesn't really matter which one. Eeny, meeny, miny, mo. 10. Okay, 1. Yep, 1 is a factor of both. 2. No 2's here. 5. No 5's here. 10. No 10's here. Oh, so this is a little bit different here. Our only common factor is 1, which also means our greatest common factor for 10 and 21 is 1. And when the greatest common factor for two numbers is 1, we can say that the two numbers are mutually prime or relatively prime, and there's one more way to say it, they are co-prime. You could also find the greatest common factor if you've got 3 numbers. Okay, you just list out all the factors for the 3 numbers and then find the common factors. And the largest one is your GCF. But enough from me. Please try example 2. Can you find the greatest common factors or the GCFs for these 3 sets of numbers? For A, you've got 12 and 20. B, you've got 6 and 35. C, you've got 18 and 45. And one of these 3 examples, the GFC is relatively prime. Can you tell which one? Remember, share your answers in the comments. And as always, thanks for watching.